Welcome back, students. Let us come to the last problem of development of surfaces. You can come over to the sheet. Let me read out the problem for you. The problem number is 4.8 with the reference number 45 from the VTU primer. The problem goes like this. Draw the development of lateral surface of a cone whose front view is as shown in the following figure. So you are given the front view of a cone, okay, and it has got two cutting planes. One a horizontal cutting plane. This diameter is shown as 515, and this is an inclined cutting plane, inclined at 30 degrees to horizontal. So the cone is cut by means of two cutting planes, and this is the remaining portion of the cone for which you need to draw the development considering these two cutting planes. So normally what we do is, first we draw the development for the entire cone with 50 mm base diameter, and then consider these two cutting planes and obtain the section points on the development. Okay. Now if I have to draw the top view of the cone, it will be a full circle. Now instead of drawing the full circle, like in my previous video, I draw a semicircle just to make it simple. Okay. So take this point as center. You can draw the semicircle here itself. This is a semicircle. Divide the semicircle into 4 equal parts. Now call the points as A, B, C, D and E. Now project the points to the front view, and then you can draw the generators. Connect these points with the apex, you get the generators. Okay. Now when it is a cone, how do you draw the development for the full cone? You require what is theta. Theta I have already calculated. I will just write down the formula once again. Theta is equal to 360 degrees into radius of base circle divided by true length of generator. What is true length of generator? This will be the true length of generator. So if you measure that here, I have written it here, it comes to 66 mm. This comes to 66. Okay. So I have taken it as x. Then for this horizontal cutting plane, all the section points will lie at the same distance from the vertex, and that distance is this distance. I am calling it as y, and if you measure y, it comes to 20 mm. So I have done this exercise before starting this problem. So I have written down all the values here. True length of the generator 66, x is 66, so same thing here, y is equal to 20 mm. Now theta has come to 136. How did it come as 136? 360 degrees into radius of the base circle. The diameter is given as 5, so radius should have been 25. Divided by true length of generator is 66. So when you do the calculation, it comes to 136. So I need this theta value and also true length of the generator if I have to draw the development of a cone. So I will draw an arc here now with the angle as 136 degrees and the radius as 66. Now the angle has to be 136. If I start from here, the horizontal line, this is 180. Okay, so I have to reduce it by approximately 40 degrees. maybe till here. Okay. So I can show this angle as 136 degrees. This I can erase. Okay. The radius of this is 100. The radius is 66. I will just show it here. R66. Now what is to be done? Let us consider this cutting plane now. Let me mark the section points starting from this end. 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. Now if you have to transfer these points onto the development, this length whatever you have corresponds to 66. This is the dimension which is 66. This is also 66. So the points 1 and 5, because they are lying on the true lengths, straight away you can transfer them by taking the distance from the vertex or from the base. For example, let me name the section points here. Point 1, it is there at A. Point 2 is there on the generator OB, if you consider this point to be O. And point 3 on the generator OC, point 4 on the generator OD, and 5 is on the generator OE. Now only OA and OE are true lengths here. No other generator OB, OC, OD are in their apparent length. So the points 2, 3, 4 straight away you cannot transfer onto the development. How to mark the points 2, 3, 4 on the development is a question. Okay, now before you do that, if this is a full circle, you would have divided into 8 equal parts. So this 136 also you have to divide into 8 divisions. That's what I have written here. Theta by 8 will come to 17 degrees. 136 by 8 is 17 degrees. Okay, so what you do is, let us say this is 17. This full arc I have to divide into 8 parts. So this is divided into 2 now. So 4 parts here and 4 parts here I have to make. And then half of each. Draw all the radial lines. So each of these angles will be 17 degrees. This angle if you measure will be 17. Theta by 8. So normally what we advise the students to do is, first you draw this arc. You are finding theta by 8 as 17. So this you can mark 17 degrees and get this line. Let us say this is A, this is B, C, D, E, then repeat D, C, B and A. So after getting this OB, you get the length of this arc. So measure this length with the compass and just go on drawing the arcs for the other division points. That is the procedure normally we suggest to the students. Okay, I repeat once again. First you take a radius of 66, draw an arc. Don't look for the angle 136. Let us not worry about it. Just draw an arc with some included angle. Then you find theta by 8 as 17 you got. So then that you take 17. Then mark OB. This is O. Okay. So once you get this arc length, you take this length with the compass. Then take B as center. The same as radius. This length as radius. Cut an arc. Go on cutting the arcs so that you get the division points, all division points. Okay. So this is the development for the entire cone, what you made. Now let us consider the section points. 1 and 5 straight away I can mark. 1 is at A, so here is 1 and here is another 1. And 5, this is the distance from the apex. Okay, so take it with the compass. and mark it on OE. This is 5. Now how to mark the points 2, 3, 4 is a question. Okay, you can't mark this length, that will go wrong because this is not the true length. What you do is just draw its locus onto the true length. Let us say this is 2, 1 dash. Okay, now you have to measure this distance from the apex to this distance. That can be marked on the development. Okay, or this distance from the base. This is smaller, so that I will mark on OB. It's 2. This is also same 2. So you have OB at 2 places. Similarly, 3. Let us say this is 3, 1 dash. So this is the distance to be marked from the base on OC. This is 3, also 3. Then for 4, 4, 1 dash. This is the distance from the base. So from the base, mark 4 here and also here. This is a cone. So you need to connect the points using freehand curve. You can't join them using straight lines. Now if you connect them using a freehand curve, this is how it comes. So this curve corresponds to this cutting plane. Now you have one more cutting plane, which is a horizontal cutting plane. Because this plane is horizontal, all the points, all the section points will lie at the same distance from the apex, and it is this distance. I have measured it, it is coming to 20. So you just draw an arc with 20 mm as radius and the apex as the center. Take O as center, just draw an arc with 20 mm radius. Let us say this radius is 20. I have drawn an arc because all the section points will be at the same distance from the apex. Now you make this portion dark. So this forms the development. You are not going to make these lines dark because you are not going to fold at those locations. It's a cone. You just roll the sheet to get the lateral face of the cone. Okay. So this is the shape of the sheet that is required for making this part of the cone. So that completes this problem also, students. This is the last problem in development of surfaces. So it is left to your choice now. Some students feel isometric projection easy, some students feel development of surfaces easy. You have to choose wisely in the examination between these two. So the arc has to be drawn only till here. That's all. So that's it, students, from my side. I think I have done 100% justice to my subject in terms of the syllabus coverage. Now it's all with you to face the examination. I don't think those students who are submitting assignments regularly, I am very much sure that they can do very well in the examination. No doubt about that. Only thing what I want you is to get 100 out of 100. Every time there are around 20 to 30 students who are securing 100 out of 100 in this subject. This subject is also like a mathematics. You have very good scope of scoring 100 out of 100 in your external examination. Thereby you can improve your CGPA. So that's all I want from your side, and I wish you all the best for your V2 exam and as well as your IIT if at all anything is there. See you again in the college. Wish you good luck for your exams.